Ladies and gentlemen, welcome to the Beautifully Broken podcast. We are sitting down with a team from Theriome. Do you guys want to introduce yourselves and just give a little background as we jump in?
Yeah, so my name is Micah Lowe. I am not a scientist, unlike Alex here. I'm more of I don't know if you say visionary, but I'm trying to bring this vision of Theriome to reality through the business. So the reason I don't just say business guy is because I really care about this, and I want to see this type of testing come to fruition where we're really helping to drive the needle on medicine and helping people to understand what is going on with their health state and what is the root cause of some of the issues that they might be facing. So something that I'm really excited about, and I've been in this industry for quite a while. It's been 10, 11 years now. And then 2 years ago is when I met Dr. Mohr and Dr. Jasby, and we hit it off. We're peas in the pod and just trying to drive some really good science into the industry of wellness.
I love it. Alex, go ahead.
Sure. I'm Dr. Alex Mohr. I've been working with Micah now for, it seems like longer than it actually is, but we have a great team. My specialty is in the gut microbiome, basically, microbiology. I'm very interested in looking at dietary interactions, environmental interactions on how that shapes the microbiome, and particularly resilience, which is a topic that we can dive a little bit into today. But at Theriome, I serve as the director of microbiomics, spearheading our microbiome test that we can also talk about.
Amazing. I want to jump in with just talking about the microbiome because the audience has heard me talk about at least 3 different ways to look at the stool, anywhere from looking at parasitic or imbalances in the microbes from like a disease profile, from just doing something like a microbiome labs. Every test is different. And I think the thing is, we came up the elevator and I said, a lot of times I'll get these tests and it's great data, but it's really high level. If I were to hand these tests to my mom, she would have no idea what to do with it. So I would love to hear your thoughts on what is the issue with the current state of testing of the microbiome as far as the end user is concerned.
Sure. I think to answer that, we're going to have to step back a little bit and go over some broad strokes. So usually when we profile the gut microbiome, and I don't want to be, have a grossness factor with, we might have to get a little bit gross. I mean, we are talking about stool.
We're talking about stool here, so we're going to embrace it. We're not going to show any stool on this podcast, but that's Perfect. What we're talking about, team. So if you want to step away from the podcast, now is your opportunity.
Yeah. So when we talk about profiling the gut microbiome, obviously most testing is based on collecting a subsample of a bowel expression, as we like to politely put it. You can get a little bit more crude if you wish. But we know that the microbiome, when we look at the gastrointestinal tract, or more broadly, the alimentary canal, the canal that extends from our mouth down to our anus, essentially, we're talking about a 20 to 30 foot tube, okay? There are microbes inhabiting all spaces within that tube. Now, obviously, as we get down towards the colon, that's where most of the microbial biomass resides, and most of the interactions that we have with the host, like what's entering into circulation from, say, a metabolite or a metabolomic perspective, is occurring. So that's a very important site to profile. However, there are new emergent technologies that I think you're going to start seeing come out in this space, particularly this consumer space, or even if you're going through your practitioner, getting labs and so forth. What's called lab-on-chip technology. It's pH activated. Essentially, you swallow a pill, and it takes different samples as the pill transverses or goes down your gastrointestinal tract. So I think things like that are going to be really important, particularly with, if we're talking about overgrowth occurring in the small intestines, something that we can get a proxy for with a fecal sample, but it's not going to be as accurate if you're not taking that sample at a higher up region. So anyway, we know that the fecal microbiome is really what most companies are going after. Really, the technology that has made this so popular is sequencing. Okay, so this comes off the tailcoats of the Human Genome Project back in the early 2000s. That technology was essentially taken. I mean, we profiled 20,000 genes from the human. That's fine. That's great. We now see the space is pretty saturated. I mean, very saturated, as we saw at the exhibition hall. But that technology was taken and applied to different environments. Microbiome, when we talk about microbes, they're very ancient, obviously, and they've done a very good job at inhabiting any type of harsh environment. You can go down to the deepest depths of the ocean in the Mariana Trench and go into these geothermal vents, and you can find microbes doing very well When we talk about where, I mean, if you look at any environment in the world, the most concentrated biomass is actually residing in the mammalian gut. So we talk about 20,000 genes in the human. We have millions of genes in the human gut microbiome. So I mean, perhaps not in biomass. In fact, if we are able to extract all the microbes, it's not anything more than what we could actually fit in the cup of our hands, which seems fairly trivial. But when we talk about functional potential, it's utterly massive. In fact, about 50% of the metabolites in circulation in our body have been affected or modulated in some way by the gut microbiome. It's intricately tied to our health. It's an ancient relationship. And now we're finding it's very, very important for different health states. The issue with most testing available, in my opinion, and I guess I'm entitled to my opinion, they're using excellent technologies, whether it be quantitative polymerase chain reaction, qPCR. I know several labs use that. It's fine. However, usually you're going to be limited with the amount of microbes that you're going to be able to be detecting. There's also amplicon sequencing. Usually you're only getting down to the genus level with amplicon sequencing. So if you look at the tree of life phylogeny, obviously we have kingdoms like bacteria, archaea, viruses, and we can get more granular. We can go, at the family level, the genus level. Then next would be species, and then strain. Strain, you might be familiar if you're taking a probiotic. You look at the back of the product, and it will list out the strain and the colony forming units, et cetera. So that's all fine and good. When we use, like, say, metagenomic sequencing, probably the gold standard in this space, we can get at the strain level. That's wonderful. However, we're talking about thousands of different features. I give you that in a report. Just simply look at the microbes. What do you do with that? I mean, for most people, a normal clinical assay, blood chemistry is daunting enough. So if you're giving a layman or even practitioners who are newer to this space, potentially thousands of different features, I mean, I suppose you could sit down on PubMed and go through, study after study after study to start drawing associations. But the human brain, if time is limited, it just doesn't have the capability to understand all those potential interactions. So going back to the functional potential that we're actually able to detect with metagenomics, that to me is where most of the insight is going to be gleaned from microbiome profiling. What's there is fine. It's really what they're doing. That's what we want to know. What are they doing, and what are they doing in relation to our health? Are we getting a lot of bile acid tolerant microbes that might be interacting with glucose metabolism or lipid metabolism? Are we getting a lot of tryptophan modulation that can start, affecting the different metabolites that are interacting with our brain, the so-called gut-brain axis? Really, and what we've tried to do with our own testing is form health modules. Okay, so we chunked it. We have bite-sized features, and you can get a lot more granular down from there based on our subdomains that we have. But all that is informed from the function of the microbes.
Yeah. Can we talk a little bit about how the sequencing you're doing is different than some of the other standards that we mentioned before?
Sure. So right now, again, this field's about 20 years old, give or take. Originally, a lot of culturing type methods were used, and that still has clinical application. There's no doubt about that. Quantitative PCR, like I mentioned earlier, you can get a good proxy if you have to have targeted sequences to do that. So you're looking at very specific microbes, and you have a targeted panel, meaning that panel is not changing. Whatever I sample, is there or it's not. With RNA sequencing or ribosomal RNA sequencing, what we're doing is pulling out essentially the ribosomal RNA from the sample. That's a whole process in itself, not a very pleasant process when we get a whole sample or even a condensed sample. I won't bore you with the details, but basically we look at different hypervariable regions on the RNA, meaning that as we look across the phylogeny of all the microbes that we're capturing, what is distinguishing one feature to another. So we take all that data, we benchmark it against very curated libraries, and then we're able to infer taxonomy, or we're able to infer what that microbe actually is. We're not able to do functionality, okay? We can make some really broad inferences, but the accuracy is generally, I wouldn't consider 70 to 80% acceptable. And again, we're only operating at the genus level. Metagenomics is not looking at RNA, it's looking at DNA. So we lyse down the cell, we extract the DNA, we go through a QC process to make sure that we're getting ample sample, and that we can have that a discussion about sample collection methodologies, because I know there's a lot of technologies now emergent like wipes, swabs. Usually we're not getting the amount of biomass that is necessary to do deep metagenomic sequencing, where we're looking at things, say, at 10 million base pairs, which we do in our test. So metagenomics takes the DNA, we break it up into little tiny fragments, and then we sequence that. And then we reform. This is really the computationally expensive part of this process, and why a lot of companies don't do metagenomic sequencing. It's actually starting to come now more online. I think companies are better understanding how to deal with that data. But basically, we take all those little tiny sequences, we reconfigure them like a puzzle almost into these long contigs, and then we're actually able to annotate the microbes and then their function, whether we're looking at enzyme commission, gene ontology, metaseq pathways, etc. That is where I think the real gold is in the sample.
Yeah. I'd love to hear your explanation as again, you said as a self-stated non-scientist.
Yeah. So how, he brings all the science to it, but how I communicate it, because I have to understand it through my own not so scientific language, is that, so for example, you and I can have the exact same microbiome in the sense that we have the exact same species, strains even, just theoretically, but you could be really healthy and I could still have something like IBS. Well, that doesn't make a lot of sense if we have the exact same microbiome. The reason is because it's not telling you what they're doing. So if we just look at the taxonomy, which is like the species, the bugs that are there, we're seeing what's there, but we don't necessarily know what they're doing. And that's why it's important to sequence it in this way, because now we understand what they're doing. So if you and I had the exact same microbiome and I have IBS, I'd be able to dial in on, well, why is that? What are these bugs? What are these microbes doing that's causing this person to have a non-health state? And so with the microbiome, there is no one perfect microbiome. So you really have to understand the function to be able to understand the microbiome. And that's why it's important.
Yeah. I'd say, and it's an exciting time to be in health. It's like, goodness, from when we first met, now what you can sequence at home in a box and get this incredible report back. But oftentimes we find that more data doesn't lead to better health outcomes, right? You got to do something with all this information. So can we take that a step further and say, now that we can sequence and have all this information in the gut, how can we better take that data and put it into some sort of a usable format for the end user?
So yeah, that's a great point. And it's information overload. In our report, we take a top-down approach. First, one of the first main domains that we look at is essentially, are you in dysbiosis or not? So we have a dysbiotic score, what we call the gut wellness score.
Can you also say what dysbiosis is for somebody that might be hearing this? Is just like,
it's a contentious,
really high level.
Yeah, dysbiosis or a dysbiotic microbiota is a contentious term. I've generally shied away from it in the past. However, because a lot of people kind of vaguely understand it, I do use that term. I generally like to talk more about a disease-associated microbiota. So is your microbiota basically working against you versus working for you? Okay. So you can have certain functionalities that are perturbated, like we talked about bile acid metabolism, for instance, which is a main issue, particularly in the West. And a lot of that is driven by diet, not surprisingly. You can have issues with degradation of mucus. So if you actually look at in the colon, if you look at the tube, if you did a little cross section, the microbes in the luminal space inside that tube, they're not touching they shouldn't be touching the brush border. The brush border is the cells that line that tube, the epithelium.
Yes.
You have goblet cells secreting mucus, okay? They're basically offering this barrier to push out the microbial contents, because a lot of microbes on their cell wall have endotoxins, okay? These are lipopolysaccharide type molecules. Just think about the lifespan of a microbe. It's maybe living for a couple days. Okay, you'll have colonies, obviously, that are proliferating. You have microbes that have a high rate of turnover and lysing. You have these endotoxins now, potentially coming into contact with the brush border. If you have compromised gut permeability, Endotoxins enter into circulation, spur inflammation, spur meta-inflammation, are tied to any type of chronic disease that you want to talk about that ails our society nowadays. We're talking about diabetes, obesity, even issues with neurological type diseases. So a dysbiotic microbiota is basically, again, in the simplest ways I can put it, is a disease-associated microbiota.
Mm-hmm. Yeah, that makes sense. Yeah, but keep going with saying what we would do with this information. I kind of threw you off.
Right. No, it's fine. So we have a top-down approach. So we essentially benchmark the configuration of your microbiota, including taxonomy and function, okay, against 8,000 different metagenomes. Okay, so the data that we've curated is spanning multiple continents, dozens of different countries, with people of varying health issues, whether we're talking about IBS, whether we're talking about cardiovascular disease. Again, insulin resistance is just so prevalent, unfortunately. And then also very healthy individuals. And a lot of times these are people from non-Western countries, not surprisingly. But we're actually able to derive a score of where you sit on that spectrum and the underlying features and functions that are driving that. And from that score, we then get down into some really important different domains that are either going to keep you in that state, because you can be, for instance, this is where I want to bring in resilience. You can have a dysbiotic microbiota that is showing signs of maybe IBS, features associated with IBS or something like that. But you can be very resilient, meaning it's hard to get that configuration into a healthy state where we want to bring you. So why is someone's microbiota resilient? Well, I mean, you can have a lot of redundancy in functional features, things that are trying to reinforce you. Like I can almost think of it like this: if you have a ship moored, it's almost these anchoring elements that are holding you in place. So with our resilience score, we're looking at those anchoring elements and seeing if someone is in a health state, why they're in a health state, what's driving that. Because if they are, we want to reinforce those. Conversely, if someone's in a dysbiotic state, say they have a lot of functionality primed for producing endotoxin, like I mentioned earlier, we want to address those. And in many cases, we have to try to do some bottleneck events where we decrease the populations of those microbes expressing those functions, and then try to, over time, repopulate the gut with commensal microbes or beneficial type microbes. So we can get more granular with the anchors. We can look at things, not just bacteria, because when people talk about the microbiome, they're hyper focused on bacteria. That makes sense. I mean, if we look at a normal fecal sample, anywhere from 90 to 95% of your microbiome is bacteria. So everyone goes to bacteria. There's other really important elements. Okay, there's archaea. There's fungi. We now know the microbiome is huge, particularly when we talk about yeasts, okay, which, talking about overgrowth type events, very, very problematic. Viruses, okay, there's a massive amount of viruses. Now, obviously, from a biomass perspective, viruses are very, very small. They're not the same, and even to like a eukaryotic cell, tiny. However, they are really primary stewards of the microbiome because they can go in and infect different microbes, kind of hijack them, for good or for good or for worse. The microbiome is something that we really want to profile, particularly when we start talking about things like bacteriophages, which are going to be a lot more popular. Particularly, I think it's going to be taken by the pharmaceutical industry, unfortunately. But we're profiling all these different kingdoms and getting a broad picture of the anchoring elements for the resilience score and what we need to address at a functional level to bring someone out of dysbiosis. I mean, even down to the microbiome, we have, for instance, a subdomain that looks at how well your body is handling mycotoxin exposure, okay? How well you are bioremediating all the environmental toxins coming in. You can do your very best at trying to avoid mycotoxins. Say that you do a complete bioremediation of your home, you remove all mold. You're not addressing food commodities. About 60 to 80% of agricultural food commodities are contaminated to some extent. Grains are an obvious one. Coffee, unfortunately, has a lot. Even if you're, say, like, on a meat-based diet, we see mycotoxins in animals that were fed contaminated feed. Okay, this is very prevalent. And in terms of, what environment or what ecosystem is interfacing with that, it's a lot of it is occurring with your microbiome. How well attuned are the functions of your gut at handling that and making sure that a lot of those those mycotoxins aren't, entering into our circulation and affecting our health.
Yeah, it's fascinating. There's so many things that you've said that I just want to comment on. The one of the mold treatments that I did when I bought a home with black mold was cholestyramine, and cholestyramine was initially used as a binder for livestock to eat and pull those mycotoxins out because it was so prevalent in their food supply, and that would keep them alive longer to be able to go to market. It's things like you saying there is this mucus layer that creates a boundary, so the microbes are not directly touching the lining of the gut. Is that your secretory IgA?
Right. Yeah. That's part of it. Yeah.
That's a measure, right? So a lot of times we get these different markers. I mean, again, I want to say this a lot of times. This is not data typically given to, what percent of the American population looks at these things? It's very small right now, right? I mean, not many people are doing microbiome tests. It's still very small in its infancy. So I never want to say a lot of guys, but and again, in my experience, sometimes you'll get a secretory IgA, or then, I've been other people who are like, you have parasites, and they're just looking for parasites, so we're going to annihilate those. Or we'll do a gut test and we'll say, oh my goodness, Freddie, your overgrowth of this bacteria that is bad, air quote bad, is in a really high percentage in the population. But we're not looking at all of the pieces to come up with the score.
It's a univariate approach. It's a singleton type approach. And, the problem with that is we're not dealing with a single biomarker. We're dealing with an ecosystem, a highly complex ecosystem.
Yeah.
So we draw heavily from ecology in informing our metrics. For instance, everyone knows about diversity, for instance, and diversity is a common score that you'll get with the microbiome. But what does it actually mean? Are we looking at functional diversity? Are we looking at species diversity? Are we seeing a lot of redundancy across functions? How is the ecosystem operating as a whole? And furthermore, if I have an intervention, perhaps it would help to your specific case, perhaps it would help lower that specific microbe, but how is it affecting the overall ecosystem?
Yeah.
And that's very important because when you're approaching an ecosystem, we can just look at what we're doing. For instance, we're in Las Vegas, which the desert ecosystem, as we can see now, the city sprawls all the way out to the mountains. It's taken a massive assault. What is it doing overall? We have to put things in the greater context. And that's where these network analyses that we perform really are amenable to better understand the ramifications of all the interventions that we're giving. Now, in some cases, if someone has a dysbiotic microbiota, and we really do need to tackle those anchoring agents that I was talking about, there may be a period where we're going to have to decrease populations and microbial populations, and we might use some clays or binding agents, which initially may not be beneficial. But in terms of moving someone out of a highly resilient state, there might be initially some unstabilizing events that, maybe someone will have more gastrointestinal symptomology initially, but we have to have those bottleneck events to move somebody into a healthy state.
Yeah.
And one of the prime vectors when we talk about modulating the microbiome is diet, particularly when you're in adulthood. That is the main modulator of the gut microbiome. No one is taking antibiotics, full stop forever. Obviously that's going to be a main disruption to the microbiome, but diet, unless you're intermittent fasting or, doing prolonged fasting, you're consuming food every single day. And it's a drip that's constantly shaping the microbiome. So a lot of our interventions are dietary based. And I think even if you're not getting microbiome profiling, because I know sometimes it is expensive, we generally would like people to get follow-up tests to see that the interventions that we're giving are actually causing that beneficial shift. But diet is the first place I would start.
Yeah. There's so many things I want to say about that. I can only really use myself as an N=1 for a lot of this conversation. And as a result of a lot of the surgeries I did, I had very slow transit time. So I'd always look at a gut microbiome test. It'd be horrible. And we just work with the redistributing those ratios. And most of the time it was something like a Xifaxan. Xifaxan is an antibiotic that's supposed to claimed to relatively stay in the bowel. And I would always get this amazing relief. I had horrible SIBO, horrible. I would eat and in 5 minutes, the gas was so painful, I'd be on the floor. And I get this great relief. But what, we weren't addressing was transit time in the gut. We really were not addressing what happens after you run the carpet bomb on the bad bacteria in the small bowel. It always come back. And even my doctors would say, they're like, look, these windows of you feeling good, they're going to get smaller and smaller, smaller every time we did the Xivaxin. So I had to keep coming up with these different strategies. When you say we're using agents to redistribute the population, like what are some of the things you see are helpful in your clinical experience?
Well, I think actually going back to gas production, one of the most commonly used clinical proxies is the gastrointestinal symptomology rating scale. It's a 15-question scale. We're looking at upper gastrointestinal tract issues, whether it's like acid reflux, burping, or we can look at the lower gastrointestinal tract flatulence, constipation, all things associated with that. Those are a good place to start, but the majority of at least people sampled in the United States are suffering from some type of gastrointestinal discomfort. And a lot of it's gas driven. Okay, so what's producing the gas? I mean, yeah, you can do some univariate analysis, but I mean, one of the main culprits is actually methanogens. Okay, production of methane. Are you profiling the entire species and functionality associated with methane producing bacteria? Oftentimes, no, people are not doing that. So, in terms of like the dietary intake, we want to look at things that are going to be proliferating those producers and limit them in the diet, almost like a sensitivity type analysis. And that's why I really, if you can, I would advocate you at least getting a baseline to better understand what could be the culprit. Like, this is unlifting the veil from the black box, because otherwise we're just going in blind and trying all these different things, or we're looking at very, very specific proxies, which may or may not be the best way, for someone to approach it from a feasibility perspective. But if we're going in, getting a full understanding of the landscape and identifying those main nodes of intervention, that's where we can have the most success. I mean, eliminating different, food, whether it's food allergies, whether it's mycotoxin exposure, basically finding the best nutritional profile for your microbiome, and then obviously your metabolism.
Yeah. Just again, hearing the story, very, very common occurrence is in dairy farms in which they'll keep manure in a silo. It's not uncommon for farmers to pass away. They'll go in there and they'll check on, and the methane levels can get so high in these silos containing cow manure. That happened to like a family that was like a few towns away from us when I grew up. So that profile of that specific microbe in the gut creating that much, methane gas, you can kind of like connect two and two together and feel how that would feel in your poor little belly as a human.
Yeah, as a mammal, as a human, a lot of those volatile compounds are actually beneficial. So generally, when we're profiling from a metabolic perspective, the microbiome, we're looking at short chain fatty acids. Okay, so we have acetate, we have butyrate, we have propionate, valerate. We have some longer chain, short chain fatty acids that are less common, but some of those can be good, some of those can be bad. Butyrate, for instance, is very, very good. A lot of people don't know, but going back to gut permeability, butyrate is the principal fuel substrate for the brush border, those cells that line the gastrointestinal tract. You're talking about, keeping those cells healthy and also being aware that they're dying every 2 to 3 days. You're having massive turnover. So, this is not something, going back to the intervention, this is not something like, okay, you're on this 2-week protocol, you're going to do this and everything's going to be fine. A lot of these dietary changes are things that you want to keep omnipresent. Okay, because you're going to have to reinforce, that reconfiguration of your microbiome for long periods of time. Talking about gut permeability, talking about mucus is another area that we could talk about. If you're on a very low fiber diet, you have very low transit time, you're going to basically starve a lot of the microorganisms in the colon. Hungry microbes are going to look for food, right? Where's a lot of glycoproteins located? It's in the mucus layer. They're going to start eating up the mucus, and they're going to start encroaching on the brush border. And now it's like a downstream, a downward spiral where we start breaking down tight junction proteins that are adhesing those cells together. Those break down. Now we get separation, and there's a pathway for different problematic metabolites like TMAO, which is tied to cardiovascular disease, the endotoxins that I mentioned previously, which have a tremendous variety in terms of serology. Some can be actually beneficial, but most are problematic that we know.
Yeah, I mean, I'm thinking just in my head, like there's, obviously we're in the age of like internet medicine, internet influenced health. And most of the people that I follow that were originally championing something like a carnivore diet, which is primarily meat, most have moved away. Many people citing eventual like autoimmune issues and joint pain, heart palpitations. I would imagine, like you're saying, there is this move in which the microbiome community is then starting to like feed on the host. Do you think it's possible to maintain robust health eating just a carnivore diet in your experience? I don't want to throw carnivore or vegan
it's political.
I know it is, but I also want to be able to talk about it.
So I'm going to say this. I think in terms of diet and supplementation, I would view it as a bag of tricks. Okay.
Mm-hmm.
And in most cases, there's a time and a place. Carnivore diet, for many individuals, that might be a important disruptive intervention to do initially,
right,
to perhaps get rid of some pathogenic microorganisms. But I don't see this being something that I would want someone to be on for a lifelong type of regimen. I know there's some case studies out there where people thrive, and there's always going to be outliers. But we're talking about the majority of the population. I mean, for instance, I think we see a lot of people in the carnivore space that have started bringing in fruits, right? Now, what do fruits have? Well, they have a lot of polyphenols, okay? They have a lot of dietary fiber that's offering substrate for the microbes. Fiber, everyone knows about fiber. Most people don't know about polyphenols. Basically, if we look at fruits and vegetables, the things that give color, right? The primary biomodulator of actually making polyphenols bioavailable for your body to absorb is microbes, okay? Mm-hmm. So that's still a black box. To be honest, science is still actively trying to better understand polyphenolic interactions. But we're understanding that is an important component of health. Okay, I'm not saying you need to go adopt the the dietary guidelines and make sure you get I don't even remember how many servings of fruits and vegetables. But I think fruits, I think they have a place in the diet. I think vegetables, potentially have a place in the diet. I think it depends on where the person is at in their health state. And going back to the bag of tricks, what we need to best leverage right now.
Yeah. Micah, can I ask you a question?
Yeah.
It's been so long since you've spoken.
Yeah, I know. Alex is providing. I'm actually learning quite a bit. Just with what you said about the anchoring points and et cetera for resilience.
Yeah. Have you done the test?
Yeah.
Yeah. Have you done it more than once?
No, I did it initially. I mean, have very limited bandwidth, so I'm not going to add to Alex's plate.
No, listen. I know how it is.
But I have done it, and I did it for my wife as well.
Yeah, the cobbler with no shoes. Looking at the report, because you've done lots of testing, you do lots of health hacks. How did you find the interpretation of the results helpful from anything you've done before?
Initially, we had a prototype of a report, which is the one I did, and it's a little bit different from today. But the one today I find to be very intuitive. So I can go through the first initial few pages and start to develop a picture of where I sit and how difficult it is going to be for me to move from that position. So if I'm in a not so healthy state, a dysbiotic state, I can see that very visually. And then I can also understand how easy it is going to be for me to move from that dysbiotic state into a health state. That's the resilience score. And so it's starting to develop a picture. He has some other things that are going to be helpful for clinicians in the pages surrounding that too. So you'll have like a sum plot of the different microbiotic species and another chart so you can start to understand the populations and what's there. And so as a clinician, if you're informed on it, you might start to see like, what are the populations that are possibly tied to this person's health state or their dysbiotic state? But from there, then you start to move into understanding like what are the components. So that's the really high level stuff. Like where am I sitting kind of globally? And it gives me a pretty good understanding. But then I want to understand what it is that I have to do in order to shift that state if I want to shift it, or even to maintain. So like, for example, it's up and to the right, which is the green in terms of healthy. That's what the chart looks like. You have green on one side, red on the other side. So you want to see people that are in a very healthy microbiome. Their microbiome is very healthy and they have very high resilience, because that's also going to tell you, hey, keep doing what you're doing, because whatever you're doing is obviously working. So anyway, once we start to go down through the report, then we understand things like, well, how big is mold? And this person's got the mycotoxins. How big is the archaea, or how is my digestion? And then you start to kind of see the components of things and start to drag those out and say, I'm going to address this component because that's the low hanging fruit, or maybe it's the most impactful to what's going on in that high level picture. Because typically you're not going to, I could be misspeaking, but you're not going to see like, let's totally overhaul everything that you're doing. We're looking for the linchpins of health that we can take and are very actionable for us to modify. So, and then we get into the digital twinning protocol though. And that is something that we have not discussed, but that's where the interventions come into play. So like what you actually do, how do you change your diet? What are the supplements or probiotics if necessary that you need to take? And so that's a protocol that we've curated for that person specifically based on that. And we don't sell any of the supplements or make any money on the interventions. I think that's really important too, because you don't want bias. But,
that's a tough one to do, to create the test and then to build the fear around the results, and then you sell the solution is problematic, right? And I see that even in especially, I don't think it's any different from the pharmaceutical industry to the functional medicine. I don't think there's any difference, because everybody's, I think what we've proven is really hard for the human psyche to maintain discernment. I can say that as an affiliate of products that I love. I'm like, what ozone machine am I going to say? I have a machine. Yeah, I know a machine. It's simply O3, baby. What red light panel I'm going to see? I'm seeing these as people ask me the question. I'm like, oh, I do trust that person. I do have a personal experience. I try to maintain discernment, but this is the way the brain works. So can we talk a little bit about how you're drawing a conclusion to interventions based on this thing called digital twinning? Dr. Jaspy's been on, but I'd like to revisit this idea of a digital twin. Let's make it so simple, the explanation. What is a digital twin?
Sure. I'll start off real quick. And then he'll get into the more granular aspects of it. But essentially what we're trying to do is shortcut trial and error. Because if you were to take this test and get all this data or whatever test that you're doing, you're trying to figure out, okay, what are the things that are going to make the fastest or the best or the most long-lasting impact for me specifically? And then you're left to, well, I think this might be the thing, so I'm going to try that. So what we're doing is we want to shortcut that, and we do that by creating a digital replica of the person's microbiome. And then we have all of our interventions in a pretty decent understanding of how they might affect a profile of an individual. And then what we do is we simulate each one of those interventions 1,000 times to come up with a protocol that we think is the next best step for this person. It's not perfect, but it is going to shortcut quite a bit of trial and error, just like trying something and seeing how you're going to respond, because we can simulate how we think and predict how we think it is going to respond. And so we do a lot shortcutting there, but I'll let you take it.
Yeah, going back to what we were originally talking about with the number of species and strains, if I was to present all that data, which would essentially be a book, right? Mm-hmm. The human brain just simply cannot draw all the possible associations, go into PubMed, and maybe you got Neuralink or something and you can, but go into PubMed and just totally pull in all the different interventions that might affect this particular enzymatic pathway or whatever. We're really taking all that brain power through our digital twinning engine, and then providing the recommendations per domain, and then providing an impact score. So essentially, again, because I understand adherence is going to be a problem. I can give you the best possible protocol, 10 pages long. Are you going to follow it to a T? Human
history says no. No. Human history says no. If we kind of know how to lose weight, we don't do that. Period. That's why it's so groundbreaking. We have the peptide for the first time ever that actually does make people lose weight in a massive way. I'm not saying that's not without its downsides, but behavior change is a really challenging part.
Absolutely. So we provide impact scores based on obviously moving the needle in that specific domain, but also the body of evidence that is behind it. Now, I know there are some interventions that maybe have less evidence behind it, but could have a tremendous impact. So, that's a weighted score. Those are included. Okay. But basically, as say you're a clinician or say you're even a layperson, it's in a format that's very digestible, and you can go do your own research. We do have references, embedded throughout the report, as well as education. Okay, education's huge, particularly in the omics space, whether we're talking about the genome, the proteome, the metabolome, the microbiome. We understand the translational piece is often lacking in a lot of these reports, and we can't just do a data dump on you. There has to be some type of translation, some type of education, and then also understanding, okay, I'm doing this particular intervention. What is this going to be affecting and how? I mean, we're not going to be as verbose as like a publication, but if you want to go seek that out and really get into the weeds, you can certainly do that. Now, going back to digital twinning and what's informing that, it's really taking all the domains. And there's some domains that we haven't talked about. For instance, we have a full probiotic panel, okay, something more clinically, what people might see from other tests, for instance. So we're seeing like what your microbiome, you're not going to be able to do much if you're taking probiotics indiscriminately. Your body, your specific microbiome is going to be more receptive to some microbiome strain, or probiotic strains than others. So seeing what's going to work best with your configuration. We also look at antimicrobial resistance genes. Okay, we know particularly we have a tremendous amount of exposures, whether it's through oral antibiotics, the environment that we're in. We look at specific genes related to that. So maybe in the future, if you do have some issues, maybe you want to consider some more traditional type approaches. We know there's many natural remedies that can do a lot of these, not everything that an antibiotic can do, but maybe there's other alternative workaround strategies. We also look at, we do have a pathogen and parasite panel. I initially I was hesitant at including that. However, based on what we're seeing now with different individuals, particularly individuals that have the environmental exposures, everything. I mean, are you living with pets? Are you living around animals? Are you? What's your water source? You were talking about your house, for instance. You had to do a bioremediation of mold. I mean, all that's going to be very important. And at the very least, we can check that box. Okay. Mm-hmm. You don't have an issue there. We can check that box. It's not this big, vague black box issue anymore. So we have all those different domains that are informing our digital twinning analysis. And, I always kind of like to step back and talk about things from a broad perspective. Digital twinning has been around for over a decade. It was actually, and not that NASA is anything nowadays. I know that they've kind of been shelved in terms of what we're seeing now with Elon. But, this technology was from basically aerospace. So they were trying to look at going back to efficiency, they were trying to look at an efficient way to test different aircraft components. Because if you think about piloting aircraft components, how expensive is it going to be? Like, how is it going to do at this certain altitude? How is it going to do under these temperatures? Very, very expensive. People just, with the limitations and manpower, doing these simulations is just saving so much time. So we see it in engineering. We like to think that we're kind of spearheading it in this personalized health space. Maybe we are, maybe we're not. We are confident in what we're presenting. But this really is to help to get you to those anchoring elements right away. Mm-hmm. You can go get more granular if you so decide, but it takes out a lot of that guesswork. So you can kind of know what to do, why you're doing it, and go from there. Versus, okay, you have acromancy and mucinophilia. There you go, buddy. Take that result.
Yeah. And so anchoring elements, is that walking 10,000 steps a day? Is that 8 hours of sleep? Is that incorporating fiber, polyphenols? Like what would some of those be, or could they be on the test?
Right. So, I mean, the bread and butter of the interventional library is dietary based, as I alluded to. There are, of course, different lifestyle factors that we know are important. And
even exercise. Yeah.
Even exercise. But the issue is, and I think this is something that frankly plagues this space, is we're all wanting, I mean, a silver bullet it feels good, right? And you get all jazzed up on it. And but you said it very, very simply, and I think very well. We kind of know, I mean, at least grossly, what to do, right? We kind of know what to do. Do I need to be chasing silver bullets? I'm not hunting werewolves necessarily, but some of this, maybe the most non-sexy things are things that usually move the needle the most. How is your sleep hygiene? What's your blue light exposure like? Have you done a sweep of your house? Do you have some black mold that you didn't know about under your crown molding? Things like this really move the needle. I mean, particularly diet, which I can tell you, most people, even if they think they're eating a good diet, they could use some work.
Yeah, yeah, 100%. So my next question is, if you have a clinical experience now. You've been running a test.
Well, I'm not a clinician. I'll be very clear about that. I'm a scientist.
However, but you are collecting data
Correct.
from a database, and you're reviewing that. So you're seeing what comes in. Is there anything you're shocked by that you were really surprised when you started to see all these stool samples come in, and either it's a trend that you're seeing within the human population that you didn't expect, or is it just pretty much what you thought it would be?
So when and Micah can interject here, when we started building out this test, again, me coming from academia, I'm exposed to all the latest research. One of the main things that I think really offers unique insight into what we're doing, I mean, from any genomic layer or any omic layer, is bringing in different facets of ecology. And I think, that the different fields of study, I think in many ways academia is siloed, but we have to draw from all these, whether we're drawing from engineering with digital twinning, whether we're looking at ecology, environmental stability, and resilience. This is not something that we initially considered in the test. But we started looking at longitudinal data of large data sets, like what we curated for all our reference ranges in our test, over 9,000 metagenomes, 8,000 for our gut wellness score. But what we started noticing was, well, resilience, we can do these interventions, but if people are resistant to change, like what's going on here? So we started to think about forming a resilience domain. And I think resilience can be utilized for metabolomics. I think it could be utilized for even normal clinical assays, even how resilient is your glucose response if you're doing CPGM, right? I think the idea of resilience and drawing from other fields of study have been massively revealing, and I think are going to be the key to really pushing us forward. Even resilience in behavior. We know that mental states are. I mean, behavioral aspects is a whole nother discussion that we could have. But I think resilience is extremely undertapped and very, very important when we talk about health states.
Mm-hmm.
Yeah, I guess mine isn't so much on the data that was collected, but thinking back to the first interaction I had with Panise, who's our colleague, our partner, is when he was talking, and this was a very informal Zoom call. He was still just doing research at ASU. We had some friends on the call. He jumped in to do a presentation with Tom Seeger, who I think mm-hmm. on recently. Anyway, I immediately, it clicked. It made so much sense to me that this is the future of understanding, because in the industry, I, for many, many years have been in this and working with people through the phone, through emails, et cetera, and grew a company with ozone therapy. But the thing that I saw is that you go into an exhibit hall like this and everybody is a hammer. I have this thing and I view health through the lens of my intervention, my thing that I do. And so relatively, regardless of what the person is facing, what I have is your solution. But on the consumer side, somebody that's trying to figure out what's really going, like you've gone through this, you're mm-hmm. just trying to figure out what's really going to help me, right?
Yep.
What is the thing? Because I go and talk to, and I'm not saying they're bad necessarily, but you go to talk to all these different products, all these different supplements, nutraceuticals, et cetera, and they tell you, yeah, it's going to be really good for you. Mm-hmm. Right? Most people will. So there are straight shooters that'll say, like, I'm not sure, you could give it a try, like all that kind of stuff. But that was kind of the big issue that I really saw, is like, I wish I could just And for many years, just like, how can I drop this to people? And I even had my own ideas of creating a social proof platform, essentially, where people are logging their interventions.
I love that.
With their disease. And like, this was something that I had thought about many years ago. But when I came across these guys, it just really clicked together for me. It's like, we can get essentially a map of human biology through multi-omics, which is when you incorporate the microbiome with the metabolism and these other layers, as he alluded to. And then we can simulate what we think is going to be effective for them. And then we don't have any bias on what they do. So we don't care what you do. We don't care if it's like, you got to stick your head out of this window for 10 minutes and that's going to cure your cancer, or you got to go do 400 rounds of chemo. Like, it doesn't matter to me from a financial standpoint. Obviously, I prefer it's not 400 rounds. But,
of course.
But knowing that, but I think it's going to bring us to a point where we have so much data and so much understanding of what is going on with human biology and mapping that to the interventions. Like, is that chemo going to work for you? Well, we can figure that out, right?
Yeah.
Because we don't have any financial bias and we have all the data on it. And so like, it's going to bring us to a point that I think is really exciting, which is really just helping people to drive the needle of their health and have clarity on that. So that's why it's so important that we maintain no bias in what the person ends up doing. But anyway, kind of a long side ramble there to what surprised me. But I think the thing that surprised me getting into this is like, it felt very clear to me. And like, I think coming from a guy who owns a business, and you probably experienced that same thing, is like people just trying to figure this out. It was a very clear problem to me. Physicians, I thought, would just kind of snap. It would snap for them in the same way. But what I'm understanding is like, these are new terms we're unfamiliar with. And it's totally fine, by the way. It's just the reality of things. These are new terms we're unfamiliar with. And this is getting into a space that I don't know, like, do they even recognize that perhaps we're looking at this from a univariate perspective, meaning that we're just breaking down the picture of your health into these couple biomolecules and saying, well, I think you should do this, whereas like resilience is looking at how you're functioning, your propensity. And so I think it just kind of surprised me that it didn't click with people in the way that I thought it would.
Yeah.
But
well,
I think we have to kind of reformat how people are thinking. So long term, what we're driving towards is not viewing health as byproducts, state of being, right? You viewing, like, if I were to go into a room and ask people what is health, usually they'll say their vitality is good, they're pain-free, they're disease-free, etc. That's the output. That is not what health is. That is where you want to be, but that is, as a practitioner, not what health is. Health is something much deeper to a person. So what you want to understand is, what are the core components that create that state of being, that thing on the outside. So you've seen the iceberg picture, right? The tip of the iceberg.
Yeah.
That's your state of being. You want to understand the things that are 90% under the water that you can't really see, that are what create the state of being.
Yep.
So that's what we're trying to get to with this. And so resilience is kind of a little bit of an unveiling of that, but we think of it as SPAR. So stability, plasticity, adaptability, and resilience are the four staples of health.
Say those again one more time.
It's the core of health, but we're getting closer to it. You can never view health in its totality. This is getting a little bit deep, but you're looking at abstractions of health. So we're trying to create but there's stability, plasticity, adaptability, and resilience.
Yep. Yeah. I wanted to add, what I would love to do, and we're almost at an hour, so I want to be mindful of everybody's time. I would love to do the test, and I would totally walk through my results. Are we allowed to? Can we legally do that? Can we walk through like a consult and like do like a video share of like what happens downstream?
Yeah, maybe we'll say, we won't tell you to do it, but if you had a doctor here, somebody else, that doctor might tell that person you should do this, Freddie.
Yeah, I really think the only thing I think, it's, we say, this is the norm, and I don't think it's such a small portion of the population that understands we can like look at the body in this way and approach health. Again, it's not about going for better supplements. It's not about pushing harder. Sometimes it's understanding what the internal environment or milieu is producing as a result of my interaction with my home, my business, my gym, my partner. And I think this tests like this, it allows us to look at the body in a whole different way. And I really think it's like, I think if people could really understand it and see it, and they're like, oh, I get it, I think it would just be I think you're breaking open Hoover Dam.
Well, I think it's a holistic view. I mean, it's the term of looking at your collective genome, whether you're talking about host tissue or microbial tissue, is called the hologenome. Okay. As I had mentioned before, about 20,000 genes, right, in the human genome, millions in the gut microbiome. I mean, we're talking about over 90% of your genetic content is actually not even your tissue.
Yes.
So when we talk about your health state, we're talking about the holobiome. That is you as a unit, if you will. And I think I don't want this to be a black box anymore. I don't think it needs to be. I think, while we don't have everything figured out, I think we're starting to, pull back the curtains. And I think that's really important, particularly for people that have issues health issues that traditional testing hasn't addressed or hasn't uncovered. And, getting at functionality, we really are getting at mechanisms of action. If you want to tackle something, you need to understand actually what's going on under the hood, not just taking broad biomarkers. I think it's not the right path.
I would go one further than that and say, anybody who hears this podcast, if you're looking to, because right now, if you go identify an imbalance in the body, be it blood sugar, be it lipid content, you're going to get you're literally getting a Band-Aid to manage that like bad test result. You're not going 3 steps before, and tests like this are going to allow you the potential to either have those things never develop or reverse through, again, looking at this holism picture, because it's just I think it's such an opportunity. I hope people explore it. Where can people go to find this test?
So our website is therio.me, which altogether spells out Theriome, but it's THERIO .me. And so you can find information on that. In regards to the ilia microbiome test, which is what we've been talking about today, that is through a physician at this point. We just don't have bandwidth to work with all the different patients and that kind of thing. So we are funneling information by working through the physicians. However, if somebody goes to our website, they can learn about it just in the same way a physician would. Or they can, and they can download the sample report. They can do different things. But also, if they email us, we can connect them with somebody a physician that can order the test for them.
Got it. Or can somebody, let's say Sally from Ohio wants her physician to start carrying the test.
Oh yeah, absolutely.
Someone could self-submit. You're like, listen, I want my practitioner to look. That's what that's the other thing. It's like similar with, I work with Flowpresso. Flowpressos are not everywhere in the USA. So a lot of times I'm like, give me your doctor's number. This is what this would look like if it was in the office, or, we have a locator obviously, but if there's 2 or 3 in a state, that's not feasible for people. So I really do think it's a great opportunity for the end user to step up and advocate for the stuff that they want in their office. Your dollars speak volumes in this marketplace, and certainly a great opportunity.
We will have it open to everybody in the future that's the plan.
Yeah.
We'll see how things morph. But for now, we just have to kind of throttle the amount of communication we have with customers. And we do that through the doctors. It's been really helpful. So.
Yeah. Well, I think it's also good to go in steps, do what you guys can handle, so you're not in a state of perpetual overwhelm. And yeah, I'm glad you guys are starting with this. I'm glad it's an option. Just to be clear, you got to go through your doctor to get access to this test. But they can reach out through the site, and this is something that, again, people can add on to the previous test, which we didn't talk too much about. But I will find the episode with Dr. Jaspy in the show notes, and I'll link that back in to look at your metabolic activity. Do the tests, if we're looking at the microbiome and the metabolic activity of all your cells, do they interrelate?
Well, that's a great question. And next year, we're going to be performing an integrative analysis where we're taking your blood metabolome, we're taking your microbiome, we're bringing those 2 data sets together to either even uncover more nodes of interaction. And really, that is going to be the full realization, at least from what we're doing, for what we term multi-omics, which is, in my opinion, the future of precision medicine.
And I think we're the first to do like a full multi-omic integration if we get that in. I mean, we'll see what comes up. Everybody's talking about it. And some people say we do it, but they'll grab a few biomarkers on that layer, a few biomarkers on that layer, or make just really big inferences. And so to my understanding, this is kind of the first version of what would be even acceptable in science.
Yes.
You know, like that, this is really the first true multi-omic integration. And I haven't seen anybody say we do multi-omics, but I'm guessing it's out there. I'm not seeking it out, just with how much I've seen people start to talk about the omic sciences in the last year. So
yeah, beautiful. Awesome. Well, gentlemen, thank you for taking time away from the busy event at A4M. We're here in Las Vegas at the Venetian, or we're in a different hotel, aren't we?
we're in the plaza, which is part of the Venetian.
Part of the Venetian, and we're looking over the desert. It's so beautiful. I was so I'm amped up and invigorated to learn more about gut function through this test. Sounds really exciting, really fun, and I applaud the work you're doing. And I'm sure it's tireless, and it's also needed. As I think we've heard today, it's like a problematic. We've said the word black box. We've said the word silo. We need a better way to look at the body. Before we go, can I ask 2 cancer questions?
Sure.
Great. So cancer is coming up a lot and on the podcast, probably the most, the hottest topic right now, probably because I went through some wild experiences in that realm, and then, people associate me with that. So I get a lot of questions, and people are always they're always looking like, what else can I look at? How can I better inform myself? Is there any information that something like looking at the gut function through a test like this adds to our conversation about cancer at this time?
So cancer is a pretty hot button item.
Yes, totally.
yeah.
And we want to be compliant.
So I'll be very open and transparent.
We can just talk about the
we currently
biological aspects.
Sure. But I want to say that we are currently not having any cancer specific domain in our test. I think when we actually perform the integration that we just talked about, that's when we can start looking at those potential interactions. Maybe you can talk further about this, but really, when we talk about cancer, I mean, obviously there might be a genetic basis for some type of cancers, but I think a lot of this is environmental. And in terms of what we're getting from the environment, I think the microbiome is a great first place to look at, because even like with the foods that we're eating, before it goes into the host and interacts with the metabolism, for instance, if we're looking at the metabolome, it's interacting with microbes, right? And we know that there are certain associations with particular microbes that are associated with cancer. A lot of that research is based on association or correlation, which is not the strongest, in terms of cause and effect. But I think once we start doing these multi-omic integrations with the full scaffold of systems biology, that's going to open up new frontiers. And I think cancer is going to be a big part of that.
Exciting.
Yeah, and to his point earlier about over 50% of the molecules in your metabolism, and we're talking about something that is very metabolically intertwined. The microbiome is a really big component in that. So I guess my question back would be, wouldn't you want to track and see how your microbiome and your metabolism are adapting over time in response to maybe treatments you're doing or the cancer? And I'm not saying it's a direct correlation to the cancer, but just looking at your metabolism and your microbiome, how are those elements adapting, I think could be really helpful. And yeah, I think the multi-omic integration is going to be a mainstay over the next, I don't know when it's going to come out and be a big thing, but it's going to be in a couple of years a pretty big deal, even in more the conventional allopathic areas.
Yeah.
I think.
I don't want to overstate what we're doing. I want to be fully transparent. Because our team is smaller, we have a certain agility. We have the ability to rapidly iterate. So we don't have everything figured out, cancer including, but that is something that I think the integrative analysis, we can start heading in that direction.
We'll go for FDA approval. Yeah. And by the way, we don't have any plans of getting bought out. We're kind of riding this ship. I think we, at least for me, I really just want to see this go in a good direction and turn into a really good thing. And so, we're not building this company with, the dollar at the end of it. We want to make a living and we want to do well and all those things. Everybody really does. But we really want to provide value, because in a world of so many people that are just seeking the dollar and will by any means necessary get there and not really provide real world. I mean, you see this all the time in academia, right?
Yeah.
I mean, they're out there researching all sorts of stuff, like totally disconnected from reality. And that's the same with business people, though, is like they can be totally disconnected from the actual outcome that they are driving. And so I just want to iterate that because I think it's important. We really want to see this come to life to where this is something that is really, really impactful for people.
Yeah, exciting. Are you guys, you're not currently looking for investors or partners at this time?
Oh, we have people approach us all the time, but no.
Yeah, great. It's good to hear. I'm so stoked. Well, we'll do it again with this. We could do 10 podcasts and probably have a different conversation every single time. I just even like going back, I'm like, oh my goodness, the idea that there's a viral biome.
Or biofilms, or even the fact that, I mean, if you look at structures like the appendix, everyone thought the appendix was this inert, little outcropping. We now understand that
an accident.
Well, if you have
it in there,
if you have a massive insult of antibiotics, the appendix is actually one of the most important structures for actually holding inoculum for repopulating your gut microbiome with healthy microbiota. So, I mean, yeah, we could have endless conversations. It was great to be part of this, and hopefully people got something out of it.
Yeah. And I mean, that's not just a made up fact on the internet. That's true. That like the appendix really does have like your mother's initial sample of what your gut microbiome looks like.
Correct.
Yeah, it's wild. It's wild. I know. It's so cool. So we'll do it again, and really appreciate your guys' time. And this was a Beautifully Broken podcast. Like, subscribe, follow, celebrate. And if you like this episode, definitely just stop over and give us a review. I say that in the outro anyway, but makes the world go round. Thanks, team. Big love.